Hi Francis classes. Today we're going to do a little bit of math with our entomology. We're going to determine how long a fly has been developing based on something called accumulated degree hours. So let's take a look at something we're familiar with now, the life cycle of a fly. So we know that a fly goes through several stages in its life cycle, but it's important to note that each stage takes a certain amount of thermal energy in order to go from one stage to the next. So for example, this diagram is telling us that at 70 degrees, our fly is going to take 27 hours to go from its first instar to its second instar, and so on throughout its phases of development. Essentially, insects need to cook a certain amount of time in order to go from one stage to the next, and we can use that information in order to help us calculate PMI. Our knowledge of the development of these insects comes from a lot of research. So in the lab, scientists are going to determine how long an insect is going to take to go from one stage to the next if we control the temperature. But there are things out in the open, if the insect is in the open environment, that we can't control. The main one being temperature. So the insect will develop at different times depending on what the ambient temperature is. Also, other weather conditions. Wind, for example, might prevent an adult fly from getting to a body quickly. Also, humidity and precipitation. Flies don't fly in the rain, so if it's been rainy the past few days, you might have to add some time to your estimation for PMI. There's also other artificial conditions that we have to take into consideration. For example, if the insects did not have access to the body because the body was buried or in a trunk or wrapped up in something, or also if the body has any significant toxicology findings. So for example, if the person was under the influence of a sedative, then that would slow the insect's development. If they were under the influence of something that was a stimulant, like cocaine, for example, then that might speed up an insect's development. So we would have to know these conditions as well. But the main one that we're going to focus on today is temperature. So if we look at a temperature across a day, we'll see that it varies. And in this particular example day, it varies quite a bit. It goes all the way down into the 30s and all the way up to nearly 80 degrees. It's a little bit exaggerated, but it's just to be used as an example. Now, flies don't develop below a certain temperature, which we call the threshold temperature. It's typically somewhere around 50 degrees Fahrenheit. So what we need to do is figure out how much cooking an insect has been able to do over a period of a day, for example. So we need to consider how much time the temperature spent below 50 degrees, right, in this area, and how much time the temperature spent above 50 degrees, the amount of time in this area. I could do that with some calculus, but I really don't want to, so we're going to make this a little bit easier for us. We're going to just consider the average temperature for the day. And if we consider the average temperature for the day, the amount of thermal energy that the insect receives is as easy as finding the area of a rectangle. So how do you find the area of a rectangle? That's right, we usually measure the length and the width, right, and multiply the two. We're going to do basically the same thing here, except instead of inches or feet or something like that, we're going to use temperature. Our average temperature for that day that we just saw was 58 degrees, and we know that a day is 24 hours long. So the total amount of thermal energy that this insect would have received over the course of that day would be the time times the temperature. Right? In this case, 58 degrees times 24 hours gives us 1,392 degree hours. So you can see how we get the unit. It's degree hours, degrees times hours. Right? So degrees hours is determined by taking the temperature and multiplying it times the time. So for example, how long would it take, or I'm sorry, not how long, how many degree hours does it take to go from an egg to a first instar? Well, let's say we know that the temperature is 75 degrees, and that it took 22 hours for the fly to go from its egg to its first instar stage. How many degree hours did this insect receive? You should have gotten 1,650 degree hours. 75 degrees times 22 hours would have given it 1,650 degree hours of thermal energy. Now we have the ADH, the accumulations. We don't just calculate degree hours, we calculate accumulated degree hours because we want to see how the insect develops across multiple stages. So let's say, for example, we want to know the degree hours it takes to go from a first to a second instar. And again, we're going to be at 75 degrees. And we measure in the lab that it's going to take 29 hours to go there. So calculate for me, what is the degree hours it will take to go from the first to the second instar, given this information? So you should have gotten 2,175 degree hours. Now, if we want to take a look at how many degree hours it takes to go from the egg to the second instar, all we need to do is accumulate the two different stages that we just calculated. So we use the egg to the first instar degree hours and the first to the second instar degree hours. So what would be the total number of degree hours that this fly needs to go from egg to second instar? Adding those together, you should have gotten 3,825 degree hours, meaning that it takes 3,825 degree hours of thermal energy in order for this insect to go from its egg to its second instar stage. But in forensics, we often don't know the time. We don't know how long the body has been out there, and we don't know how long the insect has been developing. So for example, how long would it take to go from an egg to a second instar at 68 degrees? And now before we had 75 degrees, but now it's only 68 degrees. Well, we just determined that the accumulated degree hours to go from the egg to the second instar was 3,825. This number doesn't change. You can vary the temperature, but it's still always going to take 3,825 degree hours in order for this insect to go from egg to second instar. Well, now I know my ADH and I know my temperature, but what I don't know is how much time it's going to take. However, I do know my equation for ADH, which I can use to calculate time. So right now, rearrange this equation to solve for time. You should have solved for time as being equal to the accumulated degree hours over the temperature. And now I will plug in the information I know, 3,825 degree hours over a temperature of 68 degrees. So how much time will it take for this insect to go to its second instar when the temperature is only 68 degrees? You should have gotten 56.25 hours, right? Hours, okay? Which is 2 days, about 2 days and 8 hours that it would take at this temperature. Okay, you're going to try a few more of these in your notes that you have, and please ask any questions that you need to, and then you should move on to doing the ADH practice.